Today, I will going to talk about Mesos, a platform for fine-grained resource sharing in data center. Here is that I will talk about. The first one is the motivation. Um, Nowadays, clusters of commodity servers has become a major computing platform, power both large internet service and a growing number of data-intensive scientific applications. And it seems clear that new cluster computing frameworks will continue to emerge, and that no framework will be optimal for all applications. So the scientists have some new idea. The first one is that multiplexing a cluster between frameworks to improve the utilization and allows applications to share access to large datasets, but it may be too costly to replicate across clusters. The second one is like many frameworks like Hadoop is developed independently. There is no way to perform fine-grained sharing across frameworks. So we will face many challenges. This paper's tour Mesos have those challenges. So those challenges the paper meet. The first one is that each framework will have different scheduling lists based on its programming model, communication pattern, task dependencies, and data placement. Second, the scheduling systems must scale to clusters of tens of thousands of nodes running hundreds of jobs with millions of tasks. Finally, because all the applications in the cluster depend on Mesos, the system must be fault-tolerant and highly available. So let's talk about the target environment that we want to implement the Mesos in. The paper introduced us a very interesting example about Facebook. Hadoop data warehouse at Facebook. Let's introduce you this example. Firstly, Facebook loads logs from its website service into a 2000 load Hadoop cluster, where they are used for applications such as business intelligence and advertising optimization. In addition to those product jobs, the cluster is also used for many experimental jobs, ranging from multi-hour machine learning computations to 1 or 2 minute ad hoc queries submitted interactively through a SQL interface. So this diagram shows like how long will those jobs take. As we can see, most jobs are short. And for example, the median jobs is 84 seconds long. And when the jobs are composed of fine-grained map and reduced tasks, the median task is 23 seconds long, as we can see here. So, in order to meet the performance requirement of those jobs, Facebook uses a file scheduler for Hadoop that takes advantage of fine-grained nature of workload to allocate resources at the level of tasks and to optimize data locally. But unfortunately, This means the cluster can only run Hadoop jobs. It's like if I want to run MPI jobs here, then it may be not very efficiency because the cluster cannot allocate the resource to different frameworks at the same time. So if we can use the cluster, use the Mesos for this cluster, it will help a lot. Then let's talk about the Mesos architecture. This picture shows an overview of Mesos. As we can see, Mesos consists of a master process that manages source domains running on each cluster node, and frameworks that run tasks on those slaves. And we may have many masters, and one master will connect to all the slaves, its slaves, and it will connect to all the framework it's going to use. Let's talk the Mesos master first. As you can see, the master will be the key of the whole system. The master nodes implement fine-grained sharing across frameworks using resource offers. So let's talk about the resource offers architecture. Here's show the resource offers architecture. Each resource offer is a list of free resources on multiple slaves. The master decides how many resources to offer to each framework according to an organizational policy. We can use field sharing or priority sharing, something like that. But you know, different environments may have different requirements. So, to support a device set of inter-framework allocation policies, Mesos let organizations to define their own policy. So, it makes the whole system more flexible. Each framework running on the Mesos contains of two components. As we can see, the first one is a scheduler. There has a scheduler that registers with the masters to be offered resources, and an executor process that is launched on the slave node to run the framework's tasks. While the master determines how many resources to offer to each framework, the framework scheduler selects which of the offered resources to use. When a framework accepts offered resource, it passes the Mesos or description of the tasks it wants to launch on them. So let me take a very simple example to let you understand that. First, I will show you how a framework gets scheduled to run tasks. In the step 1, the slave 1 reports to the master that I have 4 CPUs and 4 GB memory free. Then the master evokes the allocation module, which tells it the framework 1 should be offered all available resources. So, in the step 2, the master sends a resource offer describing these resources to framework 1. In step 3, the framework's scheduler replies to the master with information about 2 tasks to run on the slave using 2 CPUs and 1 GB RMA for the first task, and 1 CPU's 2 GB RMA for the second task. Finally, in the step 4, the master sends the tasks to the slave, which allocates appropriate resources to the framework's executor. which in turn launched the two tasks. And as we can see, because one CPU and 1 GB RAM are still free, the allocation module may offer them to the framework too. In addition, this resource offer process will be repeated when tasks finish and new resources become free. But in order to maintain the same interface and enable the framework to evolve independently, the Mesos gives frameworks the ability to reject offers. It's like, I have 4 CPUs to offer you, but I will say I don't need 4 CPUs. Maybe it's not good enough. So the frameworks can reject resources that don't satisfy its constraints in order to wait for ones that do. Those settings give the whole system a very good performance. At first, it can give the system a good performance of isolation. Mesos provides performance isolation between frameworks executed running on the same slaves by the existing operating system isolation mechanism. And then it also makes resource offer scalable and robust. The reason is that because a framework may take time to respond to a offer, Mesos count resources offered to a framework towards its allocation of the cluster. And finally, they also fault tolerance. Why? Because the whole system mainly depends on the master load. If the master load is fault tolerant enough, then the whole system will have a basic guarantee of fault tolerant. So the system, in order to achieve this paper designed the master load to be soft state. So if a new master can completely reconstruct its interstate from information held by the slaves and the framework scheduler. Then let's talk about the Mesos behavior. So in this section, this paper wants us to study Mesos behavior for different workloads. Its goal is not to develop a actor model for the system, but to provide a good understanding of its behavior in order to characterize the environment that Mesos' distributed scheduling models works well in. So here comes to one very important question, is that how well Mesos will work compared to a central scheduler that has full information about framework's performance. This paper considers this question into 2 cases. The first one is that there exists a system configuration in which framework gets all its performed slots and achieves its full allocation. And in this case, actually it's very easy to say that the system will converge to the state while each framework allocates its performed slots after at most one interval. It's like it's very simple because during a interval, all the slots will become available. Then as a result, each framework will be offered its performed slots. So for the second case, there is no such configuration. For example, the demand for some performed slot exceeds the supply. So in the second case, there is no configuration in which all frameworks can satisfy their performance. The key question in this case is, how should one allocate the performed slots across the frameworks demanding them? In particular, let's assume that there is P slots performed by M frameworks, while frameworks I request R such slots. While many allocation policies are possible, here we consider a very simple one, a weighted field allocation policy. It's like the weight associated with the framework I is its intended total allocation. So it will be more simple because we already use a weight. But there's still a challenging for Mesos. That is, scheduler doesn't know the performance of each framework. But fortunately, it turns out there is an easy way to achieve the weighted allocation of performed slots described above. The method is simply performed lottery scheduling. If I have more time, I will introduce you this scheduling. It's a very good scheduling and offered slots to frameworks with probabilities proportional to their intended allocations. It's also in the paper's reference. Then let's talk about the implementation of the Mesos. That has some basic setting. It's like we have implemented Mesos in 10,000 of C++. So the system is run on operating system X, Linux, and Loris. In order to reduce the complexity of the implementation, it uses C++ library called libprocess to provide a actor-based programming model using efficient centralized I/O mechanism. And for the isolation part, Mesos can use Linux container to isolate tasks. But actually, container is not a very good way to isolate resource. So maybe it can have more work to do in the future. For the frameworks, it's implemented 4 frameworks. The first one is Hadoop, and npm, and a very special frameworks of interactive jobs called Spark. Based on this setting, let's talk about something about evaluation. Based on my own understanding, that a very good evaluation result for Mesos should show 2 things. The first one is Mesos can achieve higher utilization than static partition, because static partition is a regular way to schedule frameworks, and that jobs finish it at least as fast in the shared cluster as they do in the static partition, and possibly faster than it. So let me show you figure. In the figure, the first figure, it compares the resource allocation over time of each frameworks in the shared and statically partitioned cluster. As we can see, that Mesos can always be faster than the static partitioning in the four frameworks. And also, as we can see here, Mesos enable each framework to scale up during periods that other frameworks have low demands, and thus keeps the cluster loads bigger. Let's look at the Facebook Hadoop mix. As we can see here, during the 100 to 200 times, the Hadoop don't have a very high demand. Then, in the Spark, during the 100 to 200 times, Mesos can allocate the Spark more resources than 0 to 100 times. So it can help framework to scale up, which makes the whole system more efficient. Here is figure 6. Also, as we can see in the Spark, there is the same thing. It shows that Mesos enable each framework to scale up during periods that when other frameworks have low demands. And in the right part, as we can see, Mesos can always show a higher memory utilization than static partitioning. And for the CPU utilization, Mesos will still show a good, better utilization than static in majority times, except the time around 1300. So the results show that the Mesos not only can help the frameworks work faster, but also helps the whole system more efficient. This paper also shows us a very beautiful table to help us understand how the Mesos help the framework works faster. It breaks down the result further by job type. We can observe two notable trends. First, in the Facebook Hadoop mix, we can see here the smaller jobs perform worse on Mesos, but for the bigger jobs, it will work better on Mesos than others. And large Hadoop mix and Spark, the Mesos always have good, better performance than the static partition. And for the MIP and Talk, the Mesos will have worse performance than static partitioning, but it's still nearly 1. And this paper said it can do further work to improve the Mesos in those ways, but we can still say that the paper and the Mesos is a very good efficient tools to help scheduling different frameworks in the same cluster. Thank you.